Alright, in this video, we're going to move on from our binary serializer for now. I mean, it does all the stuff we kind of need it to do to get things going. Our API for our serializer is pretty much all in place with our write arguments and read arguments. I might be adding an overload for these maybe later that takes in a method info or some parameter infos instead of a type array, maybe to speed things up a little bit. We'll see how that goes later. In our serializer, of course, we support everything from arrays to value types to nullable types, and then we have a handful of built-in types that we support at kind of an atomic level. Now, we'll definitely be adding to our primitive types as time goes on, as we introduce new complex types such as an actor ID. But for now, I think that this is perfectly acceptable for getting our system moving along. So I want to start to talk about the other little components that we're going to be needing in order to have this system work. Now again, like I said earlier, the system is built upon a large array of these kind of primitive components that we're going to put together to make the system behave as it is. And by focusing on each component one by one and testing it, we'll be reasonably certain that when we put everything together, things will work. So we're getting dangerously close to building out our actual networking code, but we're still missing something. So both on the client and the server, we need a sort of in-memory representation of what's going on with the system. So if you recall from the overview video of this chapter, we kind of separated our RPC aspects into systems, which support bidirectional communication between the client and the server, and then we have our behaviors, or our actor RPC interfaces that are attached to actors. And I also talked about how I wanted this system to take into account things like the position of the actors and which region they're in, and interest management, all that fun stuff. In order to get to actually writing viable network code as soon as possible, and so we can start talking about things like putting together our GUI and all that fun stuff to get some basic systems going and some communication going. I'm not going to focus quite yet on the actor implementation. I want to see an end-to-end implementation of our systems first, so that we can support one-on-one bidirectional communication between the server and client, instead of the one-to-many unidirectional communication from server to client for the actors themselves, the actual movable bits within the world. And again, like I said earlier, that's going to require that we have this in-memory representation, both the client and the server, about this stuff. So basically, the client is just really going to be a combination of these loosely coupled components. We're going to have something called like the client transport, which is responsible for the network communication. We're going to have our client systems, which is responsible for the systems that we're going to be creating. And we're going to have our client world. And the client world is responsible for knowing what actors are on the table and all that stuff. The client context is also going to be a place to put things that need to be referenced globally, like the different subsystems. For example, the ability database, the item database, the quest database, the GUI system, and all that fun stuff. So that's actually going to be composed on the Unity side. What we're seeing right here is we're seeing the Visual Studio solution that contains all of our reusable code that's going to be compiled into binaries. And these are just going to be the reusable components. The thing that's actually going to go in Unity is what's going to bring them all together. So, like I said, I want to go ahead and actually build out the in-memory representation of the client context and the server context for the client-side stuff and the server-side stuff to facilitate our systems API. So again, if you recall from the first video, a system is defined as two interfaces and two concrete types. The two interfaces live inside of the base project, and the two concrete types live inside of the client and the server respectively. So a client will have a concrete type that plugs into the system, the server will have a concrete type that plugs into the system, and they'll be kind of unified between these two interfaces that we're going to write on the base project. And those interfaces are going to what defines the RPC interaction. So we definitely will need a way to sort of represent that. Because within our code, there's going to be situations where we're going to have to ask, okay, so the server is telling us to invoke or create a client-side system. Let's say the server is asking the client-side system to create the character select screen system, for example. Now, when the client receives that message, the client's going to need to know how to associate that interface type with a corresponding concrete type to instantiate. So what I mean by that is the client's going to have a concrete type called like select character screen component or select character screen system. And the system, the framework is going to need to know how to map a incoming response from the or incoming message from the server to know which concrete type it's talking about. In the same way, on the server, when we instantiate a server-side component, we're going to need to know information about that component as well. We're going to need to know what its client-side interface is and what its server-side interface is. So we really need to start thinking about how it is we are going to map these things, map these concepts in memory. And I think what I'm going to do here is I'm going to create a class, and I think I'm going to call it something like component resolver or type resolver. And what it'll be responsible for is scanning the assembly and kind of hooking up our concrete types to our interface types. So what I'm going to do first is this video will be interesting because we're also going to actually start writing some code in our .server and our .client projects. Because the way that I want this to work, let me go ahead and actually what I can do here is I can plop over a Sublime window. Let's jump over into C# formatting. So in our base project, we'll have like an interface called I character select system and server, and we'll also have an interface of I character select system client. Now in our client project, we're going to have something like this. We're going to have class character select or client character select system, and he's going to have to inherit from something. So he's going to have to inherit from something like a system base, and at the very least he's going to have to provide his server as a generic type parameter. And the reason we need this is the system base is what's going to own the proxy object, the object that's responsible for turning real method calls in C# into some sort of thing that gets translated over the wire. He's also going to have to implement iCharacter system client. So it's going to look like this. So when we have a system, we're going to have a class that looks like this. So if on my client I made it so void show character UNID string name, we would have to implement that corresponding method on our client. We would have to say public void show character UNID string name, which would perform the client logic. Now let's say our server logic has something like void select character UNID. So how would we invoke that from within our client? We would do proxy dot select character, or let's not do it in the show character. Let's do it in a in like an on GUI method, for example. So if GUI button character 1, then what we're going to want to do is say proxy dot select character 1, for example. So this would be a sort of really rudimentary implementation on the client. So this would be a mono behavior instantiated on the client that would respond to these messages. Then on the server, we're going to have the exact opposite. So pay close attention to the way I'm going to be writing this class definition. So I'm going to say class server character select system inherits from, let's do server system base, passing in iCharacter select client, and also implementing iCharacter select server. And he would look like something like this. He would say like something like protected override void awake proxy dot show character ID1 name char1, for example. And then he would also have to implement his corresponding select character method that you see in the iCharacter select system server. So select character, uint ID, And what this would do is this would go ahead and do something like client context interworld world 1. Of course, that would be received from the database to know what character was in which world. Okay, so hopefully you guys can get an idea of what's going on here and what we need to do and what the component we're about to write will do. So we have these 4 types, and again, this was talked about in the overview video, but I want to emphasize some aspects. I want to emphasize what our client systems are going to look like and what our server systems are going to look like. So our client systems implement or inherit from a base. Now this base is going to be specific to the client, so it's going to look like Unity client system base, which will also inherit from mono behavior. And you see it takes a generic type parameter. Now the generic type parameter that the client receives is going to be of the server interface. That's how we get the strongly typed proxy object. Because otherwise, how would the proxy object, which will come from the Unity client system base, how would that know what type it needs to be at compile time? It knows that through this generic type parameter. Then it implements this interface, meaning it needs to know what's the corresponding client interface for this system. Now the exact opposite happens on the server, because the server implements the server interface, so it has to implement like the select character, the doing methods. Also, that should be public void. The doing methods, right? And then it also inherits from the server system base, which provides a generic type parameter for the client object. That's how on the server the proxy knows it's hitting a client interface, and on the client the proxy knows it's hitting the server interface. So what I want to do is I want to write a component that kind of collects this information for us, because things can get very, very, very messy. In fact, I'm going to introduce some terminology here that hopefully should make the rest of the API clear of what we're writing. So the iCharacter select system server is what I'm kind of referring to as a component, because it's a thing that's mapped by the component map. It's also what I'm going to be referring to as the server or system, or how about server system type. This is also a component because it's mapped by a component map, and it's going to be referred to as the client system type. In fact, we could also make this even more explicit by referring to this as the server system interface type, and this is the client system interface type. So what are these guys, the client character select systems? Well, the client systems are going to be referred to as client concrete type, and the corresponding server side is going to be referred to as the server concrete type. So I really want to get this terminology set in stone with how we're going to write our method parameters, because we're really messing with 4 types, and like I said, things get confusing. For example, let's say we want to create a new system on the server. Let's say that when we say client context.interworld, we want to add a new system to the client. Let's say something like we want to say client context.systems.add. Let's say we want to add the chat system to the client. So we want to open up the abilities for the client to now chat by dynamically adding the chat component to this whole system. What type would we pass in here? Well, through the testing that I did earlier in the R&D portion when I put this system together originally, or a similar system together originally, I preferred to work with concrete types when instantiating them. So if I wanted to add the chat system, for example, to the client context, I would say client context.systems.add from concrete type, and then I would pass in server chat system. So the API that we would handle here when we add a system from the server is going to be passing in the server concrete type as the generic parameter. This has a lot of benefits because it means we can directly have something like var chat system equals right here, and then we can, or that's char system, chat system, then we can say something like chat system dot blah equals hey. whatever. We would have direct access to it through the statically typed thing that we're doing. So basically, this whole discussion, and I hope that people aren't ridiculously lost at this point, but this whole discussion boils down to what goes on right here. When we want to add a concrete system to the game, to a client, how do we know that the server chat system, for example, is going to result in a particular system being made? And how do we know which one it is? How do we know from this type that it implements the iServer chat system, or iChat system server, and iChat system client, for example? How do we make that association between these four types? Because remember, the server doesn't know about the client concrete types, and the client doesn't know about the server concrete types. So they need to talk through these interfaces, and they need to be able to map their interface types to their concrete types. So if the client gets a message saying the client interface type needs to have this method invoked on that, how does the client turn that interface type into a concrete type? And that's what we're going to be doing with our type registry. The type registry is going to be responsible, and it's going to be used on both client and server, so I'm going to put it in the base project. But it's going to be responsible for scanning the system and deciding how to interpret classes like these. So it's going to scan the app domain. It's going to find types that look like this, and then it's going to extract information about it so we can use it later. In the case of it running into this type, it's going to say, okay, well, it inherits from Unity client system base. So we know that it's a system implementation. Now let's inspect to see which server interface it implements by checking the generic type argument, and then let's see what client system it implements by checking its interface implementation. So yeah, we can pretty much automate this process. And have it used for both the client and the server because we know they're both going to follow this exact same pattern. The difference is this. They will both use a different base type. We'll have our unit client system base, for example, and our server system base. They'll both use a different base type, so it'll need to be able to scan for different base types, but that's really easy to do. Then it'll also need to be able to list all of the interfaces that this class implements and find out which client type that it implements, or which corresponding server type it implements. And it needs to know if it's in the client context or the server context, so it knows if this is a server or a client. Alternatively, what we could do is specify both the client system and the server system in the generic type parameters. So what do I mean by that? Well, instead of having Unity client system base of iCharacter select system server, we could have Unity client system base of iCharacter select system server and iCharacter select system client, where we know that the first is always the server implementation and the second is always the client implementation. So, that could work as well. In fact, we could also, we could also have this be implemented as a interface that is used for both server-side and client-side systems, as a non-generic interface and as a generic interface. Unfortunately, though, let me think about that actually, because I'm trying to see the future right now, honestly. I'm trying to see if that could work. Because there's a variety of ways. The problem with having a generic type like this is that it's impossible to reference this generic type without specifying its generic parameters, which makes things very, very difficult to work with. But if instead we had a non-generic system base interface and then a generic system base interface, then we could have our scanner just rely on that. In fact, actually, yeah, I'm going to go ahead and I think I'm going to do that. Select system. Yeah, let's see if that works. Okay, so what I'm going to do is I'm going to come up here to my Buzz MMO base and I'm going to create a default, two interfaces, a generic interface and a non-generic interface for system bases. So I'm going to come up here, I'm going to create a new interface, and let's do a I system base. Then I'm going to hit OK. Now, system base interface is going to have two type properties. We're going to have type server, what did I decide to call that? Server system interface type with a getter, and then a type server system, or sorry, client system interface type. The reason I want to do this is I want to be able to cast any system object into a known interface, in this case iSystem base, and then retrieve that information out at runtime to know which interface constitutes the server and which interface constitutes the client. So that way we get the whole triangle of types out of that bit of information. We get the concrete type since we already have it, and then we can extract these two bits of information out of it, which I can see being very useful. As far as the generic form of iSystem base, I'm actually not saying that is going to be being required. I think we'll only need the interface for it. All right, so let's go ahead and I'm going to write some tests for this. Before we implement our type resolver, I'm going to go ahead, or our type registry. I'm going to write some tests. So I'm going to open up Buzz MMO tests. I'm going to open up base folder, and then I'm going to create a new class, and I'm going to do type registry tests. And we're going to set up a test fixture, or sorry, a test fixture, not a test. Okay, so what's the test that we're going to be looking for here? Well, first of all, we need a concrete system base class. So I'm going to say class test system base, and it's going to have two generic parameters, T server interface and T client interface, and it's going to implement iSystem base. Okay, for the implementation, it's simply going to say get is going to return type of T server interface, and then the get is going to return type of T client interface. Okay, so now we need to go ahead and write some things that we want to map, or things that we want to be able to have registered. So I'm going to say class test server system 1, or how about just test system 1, because the code we're writing is independent of it being on the server or the client. So I'm going to say test system 1 inherits from test system base, and it's going to need to pass in two interface types, T server interface and T client interface. So I'm going to say test system 1 server interface, or how about I test system server, and then I test system 1 client. Now we need to actually write these interfaces. So I'm going to say interface I test system 1 server and interface I test system 1 client. So we can kind of like imagine this already. If we just change the names around a little bit in our mind, we can actually see a proper use case from what we're looking at right now. It's just all self-contained. So for example, we have our two interfaces, one that defines the system or the client interface, one that defines the server interface. We have our base type. So for example, in Unity, our base type would be inheriting from mono behavior, and it would also be implementing the iSystem base. And then we have a concrete type. So we can imagine this concrete type existing on the client or the server, either providing client logic or server logic, and it inherits from the test system base. Notice how it doesn't implement anything else. I'm actually not going to want to rely on interface implementation to extract that information. So basically, what is the goal here? Well, the goal here is I want to be able to receive just this class, and then be able to extract if it's or extract the two interfaces that it implements. So let's go ahead and just write a basic test for that. I'm going to say public void type registry can register system. Okay, so what's this going to look like? Well, we don't have the type registry class written yet, but that's okay. I'm going to say var type registry equals new. I'm actually going to change the terminology here. It's not going to be a type registry, it's going to be a system type registry. So we have system type registry tests, and then I'm going to say registry equals new system type registry. Then I'm going to say something like registry.register system from concrete type, and I'm going to pass in type of test system 1. Now I'm going to want to be able to perform some tests. I'm going to be able to want to determine what the server types and the client types are from the thing we just registered. So I think what I'm going to do here is I'm going to say var registered system equals registry.get system from concrete type of test system 1. Then I'm going to say registered system dot client interface type, or did I what was that, server system interface type. So server system interface type should be type of itest1 server. Then I'm going to say registered system dot client system interface type should be type of itest client. Okay, so we're extracting information about the system based off a concrete type. Let's go ahead and do the reverse, because we're also going to need to acquire information about it from the server interface and from the client interface. So I'm going to simply say registry dot get system from server interface type, passing in type of itest system1 server should be registered system. And then I'm going to say registry dot get system from client interface type of itest client should be registered system. So what I'm doing here is I'm expressing a need for a couple more methods. I need to retrieve the registered system information from a system server interface and from a system client interface. So basically, again, all the system type registry does is it just collects information about the systems and lets us get on with our lives with more important things without having to reanalyze that information all the time. So yeah, I think that should work. Let's go ahead and implement our system registry now. So I'm going to go up here to the infrastructure namespace of MMO base and create a class. I'm going to call it system type registry. Now the system type registry is going to need some methods, and we've determined the need for those methods in our tests. So we need register system from concrete type. So I'm going to say public void register system from concrete type, passing in a type parameter and passing in concrete type. Okay, so what do we do here? Well, let's go ahead and actually write our other method stubs first, then we'll implement them. And that goes along, with standard TDD practice. So we're going to need the get system from concrete type, the get system from server interface type, and the get system from client interface type. So I'm going to say public, and then I'm going to say registered system, or how about system information? No, that's very a bad name. I'm going to say registered system get system from concrete type, type concrete type. Then I'm going to say public registered system get system from server interface type, type server inter. I apologize for the long method names, but because we represent concrete types and interface types and all that fun stuff using the type, we definitely need to be very careful with our naming so that our code is more expressive. Then I'm going to say public registered system get system from client interface type, type client interface type. Okay, so these are my 4 methods that I believe I used in my test. So coming back into the test, we now see that that all works. The only problem here, however, is of course we're not returning our registered system class, and we haven't even written our registered system class. So let's go ahead and implement our registered system class. So I'm going to come up here to my infrastructure namespace, and I'm going to create a new class called registered system. And he's going to take in a couple parameters. He's going to take in type concrete type, type server interface type, type client interface type, and I'm going to turn these all into properties. We might add additional information to this later, but right now it serves as basically a little holder of data about the concept of a registered system, allowing us to translate between concrete types and interface types, which is going to be pretty much ridiculously important for what we're doing. Let's come back to our tests, and looks like we're missing the reference to fluent assertions, so we'll have that appear at the top. Registered system, looks like I changed a registered system. Oh, I misspelled something. Okay, let's go ahead and get all 3 of our registered systems correctly spelled on our system type registry. Come back to our tests. Now let's fix these. I'm going to do server interface type. Instead of saying client system interface type, I'm just going to say client interface type. I think that's short. It's shorter, but it still, I think, makes a whole lot of sense. Okay, so coming back to our system type registry, let's go ahead and implement our methods. So what we need to do is we basically are going to need 3 dictionaries, and they all point to registered systems. We're going to need to be able to go from a concrete type to a registered system, a server interface type to a registered system, and a client interface type to a registered system. So up here in my fields, I'm going to say private read-only dictionary importing systems collections generic type to registered system, and this one is going to be concrete types type to system. Say private read-only dictionary type registered system, and this is going to be server interface type to system, private read-only dictionary type registered system, client interface type to system. Let's go ahead and instantiate all 3 of these dictionaries. All right, let's go ahead and write these 3 methods first, and I'm also going to add a try get for all 3 of these as well, so that we can try to get a registered system out of this information, as opposed to just throwing an exception if we can't. So get system from concrete type is simply going to return concrete type to system concrete type. Then I'm going to say public bool try get system from concrete type, type concrete type, return concrete type to system, try get value, concrete type out, concrete type, which I will have to provide this as an out parameter as well. Or derp, I am stupid today apparently. Out, registered system, writing registered system. Okay, so I just have the get system from concrete type and the try get system from concrete type. They just delegate to the corresponding backing dictionary. So now I'm going to do it on these 2 methods as well. So server interface type, I'm going to say server interface type to system, passing in server interface type. Then I'm say public bool try get system from server interface type server interface type out registered system. Again, this stuff is very verbose, and it's very verbose because I'm compensating for the fact that it's going to be very, very easy to make mistakes with this code. So we got to make sure that we're getting and setting the correct types of types, right? We got to make sure that we're working with the server interface or with a concrete type or with the client interface. We have to make that very explicit with our naming. So the server interface type to system, try get value, server interface type out registered system. And then up here, I'm going to say return client interface type to system, client interface type. And then public bool try get system from client interface type client interface type out registered system, return client interface type to system, try get value, client interface type out registered system. All right, so that's really the boring bits of the system type registry. And our code actually compiles, so we can come back here and we can run the test. Of course, we're probably going to get some null reference exceptions. And as you see, the test fails. So let's come back to our system type registry and implement the only interesting method that we're going to have, and that is the register system from concrete type method. And all this method's responsibility is to populate these 3 dictionaries with information that was established from the concrete type passed in. So what information does it need to establish? Well, if we look at our tests, which I'm going to go ahead and dock this on the side of the screen so you guys can see both the tests and the code at the same time, you'll notice that the way that we know whether something, what the server interface is and the client interface is if it inherits from a type that implements iSystemBase. So I guess the easiest way to do this would be to loop through all of the, or well, we don't need to do that. We just need to determine if its base type implements, if its base class implements iSystemBase. And if it does, then we extract these generic type parameters. With the convention of the first parameter being the server interface and the second parameter being the client interface. Now, fortunately, this isn't stuff that you guys really need to worry about when you go on to actually use the system. It's really just implementation detail. So we're going to establish that sort of convention, I think, at this point. An alternative way to establish that convention is we could actually introduce a generic form of iSystemBase that takes in those generic type parameters. Then we just have to loop through all of the interfaces that this concrete type implements, find one that find its implementation of iSystemBase of T2, and then extract that information. I think that's going to be the best way to do this. So it's not really going to change the code a whole lot. The only thing that's going to change over here on our test, so I'm on my test right here, is that instead of implementing iSystemBase, we're going to implement iSystemBase of T server interface and T client interface. Now, of course, this type doesn't exist yet. We'll have to go ahead and write this type inside of our base infrastructure project. So remember, just go ahead and add the generic type parameters to our iSystemBase. Now I'm going to go up to infrastructure, and I'm going to create a new class. I'm going to say iSystemBase, and then tilde 2. Well, that's not tilde, that's a tick, but still, tick 2. So now we have this right here. Again, this goes with the convention of naming files that are generic type that add generic type parameters to a particular type. For its name, it's going to be an interface, not a class. And I'm going to go ahead and add 2 generic type parameters, T server interface type and T client interface type. And it's going to implement, or rather, this is a case of interface inheritance. It's going to inherit from iSystemBase. Now coming back to our tests, we see that our code does compile now. And now we have enough information to be able to easily extract what we want. So coming back to the system type registry, what I can do is I can simply loop through all of the interfaces that this class implements and find its implementation of the iSystemBase. So I can say for each var interface or inner, because interface is a reserved keyword, so I always use inner, I-N-T-E-R. In concrete type dot it get interfaces. I always wondered what get interface map did. Get interface sys. Get interfaces will return all of the interface implementations, including the ones that were inherited. Then I'm going to say if inner dot is generic type, or sorry, I'm going to say if not inner is generic type, and and inner dot get generic type definition does not equal type of iSystemBase of blank, then continue. Otherwise, I can say var server interface type, or sorry, first I'm going to say var generic arguments equals inner.get generic arguments. Then I'm going to say var server interface type equals generic arguments at 0, and var client interface type equals generic arguments at 1. Then I'm going to populate our dictionary. I'm going to say then I'm going to instantiate my system. So I'm going to say var system equals new registered system, passing in the concrete type, the server interface type, and the client interface type. Then I'm going to say concrete types to system at concrete type equals system, I'm going to say concrete type to system add. The reason I'm doing add instead of using the index syntax is because add will throw an exception if it's a duplicate key, which would be indicative of a bug somewhere in our code. Which, remember, if we have a bug in our code, we want to throw an exception. So I'm going to pass in concrete type as the key and system as the value. Then on client interface type to system, I'm going to add client interface type as the key and system as the value. And then server interface type to system, add server interface type as the key and system as the value. Then I'm going to simply type in break because we found the implementation of iSystemBase within the concrete type. All right, let's see what our test says. So I'm going to go ahead and exit full screen, open up my test runner, and hit run. And we get a success. So let's go ahead and write a couple more methods. I'm not going to even bother testing here. So we have our register system from concrete type method done. Let's go ahead and write a public well, this is actually going to be interesting. Because I want to write a method that'll scan an assembly for all types that work like that. Unfortunately, that's going to cause a problem because assume that I did have a well, actually, I can just do all types that implement the non-generic form of iSystemBase. If it implements the non-generic form of iSystemBase, it'll be scanned by our system type registry. So I'm going to write another method called public void scan assembly, which comes from system.reflection namespace. Assembly. Notice the system reflection up here at the top. Let's say for each var type in assembly get types. I'm going to say if not type of iSystemBase is assignable from type, then continue. Otherwise, register system from concrete type. Or sorry, I'm also going to say if not type dot is class and not type is assignable. How about let's say and not type is abstract. So we're making sure if it's not a class, or if it is abstract, so remove that not. So if it's not a class, these should be ors. Oh, and so should this one. On line 24 in the register system from concrete type, I got my Boolean logic wrong because Boolean logic is hard. Yeah. If it's not a generic type or yeah, it should be or. Why does Boolean logic confuse me sometimes? Okay, so our scan assembly method loops through all the types in assembly. If it's not a class, or if it is abstract, or if it's not assignable from iSystem base, then continue. Otherwise, register system from concrete type. Then finally, I'm going to say public void scan app domain, and I'm going to say for each var assembly in app domain dot current domain dot get assemblies scan assembly. Now these aren't going to be particularly fast methods, but that's okay. We could make them slightly faster by limiting what assemblies it scans, but I'm not too terribly worried about that because this is, regardless of whether or not we scan every single type in the entire .NET framework a couple of times, we're still talking about a performance hit of hundreds of milliseconds, which is not going to make a difference on startup because that's the only time the scanning needs to happen. But anyway, so yeah, we now have our system type registry. Again, it's really just a convenience class that will prevent us from having to write this code over and over and over again for different circumstances. I might extend it in the future to do different things, but for now, I think that's really all we need to do. I'm not going to be worrying about testing other things anyway as well. I think it's tested as much as it needs to be. So where we move on from here, now that we can associate concrete types with interface types, is we can start talking about our actual systems and our system factories, which will be responsible for actually instantiating the systems. And we can also start talking about our client and server contexts, respectively. Anyway, we'll see you guys in the next video.